Hello students, we shall go on to the second class under electrochemical energy sources. This is going to be under the teaching content. In today's class, we are going to study regarding secondary cell, and under secondary cell we are going to study nickel cadmium cell. In the last class under electrochemical energy sources, we had studied what is a primary cell and what is a secondary cell, and in secondary cell we had studied lead storage cell. So in today's class we are going to study regarding nickel cadmium cell. In case of secondary cell or a storage cell, these are even called as accumulators. Nickel cadmium cell comes under alkaline storage cells. Nickel cadmium cells comes under alkaline storage cell. Nickel cadmium cells consist of a nickel wire gauge electrode grids. Nickel cadmium cells consist of a nickel wire gauge. It consists of a nickel wire gauge electrode grids. The anode grid consists of a mixture of spongy cadmium with 78% cadmium hydroxide. The anode grid will contain it contains a mixture of spongy cadmium with 78% cadmium hydroxide, 18% iron, 1% nickel and 1% graphite. So it has got cadmium hydroxide, iron, nickel and graphite. Then cathode grid contains nickel hydroxide 80%, cobalt hydroxide 2%, graphite 18% and some traces of barium compound. So cathode contains nickel hydroxide 80%, cobalt hydroxide 2%, graphite 18% and traces of barium. Graphite increases the conductivity. Graphite is going to increase the conductivity. Cobalt and barium. Graphite is going to increase the conductivity. Cobalt and barium compounds increases the efficiency of the active material. Cobalt and barium compounds are going to increase the efficiency of active material and also the cycle life. Here we are going to use 6M potassium hydroxide. Here we are going to use in this, the electrolyte is going to be 6M KOH. If it is going to be a button type cell, then a cell cap is going to act as a cathode. In case of button type cells and a nickel cadmium cell, it contains the cell cap is going to contain a cathode and a cell cover acts as an anode. The cell cup acts as a cathode. The cell cup is going to act as a cathode and the cell cover acts as an anode. The electrodes consist of tablets wrapped in nickel wire gauge. The electrodes will consist of tablets wrapped in nickel wire gauge separated by fine porous separator soaked in electrolyte. Here these are going to be soaked in electrolyte and the electrolyte is 6M KOH. The sealing is accomplished by flinging the rim of the cell cup. The sealing is accomplished by flinging the rim of the cell cup over the rim of the cell over the plastic washer between, serving to insulate the cup from the cover. So here what is being done is the sealing is accomplished by flanging the rim of the cell cup over the rim of the cell cover with a plastic washer between, serving to insulate. This serves to insulate the cup from the cover. Now coming to the electrode reaction. During discharge, that is what happens at anode. At anode, cadmium combines with hydroxyl ions. Cadmium combines with hydroxyl ions to form cadmium hydroxide and 2 electrons are liberated. At cathode, nickel hydroxide combines with these electrons to give nickel. This is going to be here the oxidation state. The oxidation state of nickel in this case is +3 and in this case it is going to be +2. So nickel is going to get reduced here. At cathode it is going to get reduced. So the net cell reaction is going to be cadmium where nickel is going to get reduced and cadmium is going to get oxidized. During charging, the same reaction is going to be reversed. During charging, the same reaction is going to be reversed. The open circuit potential of the cell, ranges from 1.4 to 1.28 volts. Here, the cell potential here ranges from 1.4 to 1.28 volts. It is compact, lightweight battery with good cycle. It is compact, lightweight battery with good cycle, characteristic capacity and a long shelf life. It has got a long shelf life. Coming to the applications of nickel cadmium cell. This sealed nickel cadmium cells are used individually or assembled in battery packs containing 2 or more cells. So in battery packs I can use them. Small cells are used for portable electronics and toys. The small cells are used for portable electronics and toys. Often using cells manufactured of the same size are primary cells. The miniature button cells are sometimes used in photographic equipment, handheld lamps, flashlights or torch, computer memory standby, toys and novelties. Specialty of nickel cadmium batteries are used in cordless and wireless telephones. They are used in cordless and wireless telephones, emergency light and other application. With relatively low internal resistance, they can supply high surge currents. With relatively low internal resistance, they can supply high surge currents. This makes them a favorable choice for remote controlled electric model airplanes. Because of low internal resistance and high surge currents, it makes them favorable choice for remote controlled electric model airplanes, boats and cars, as well as cordless power tools, camera and flash units. Okay, this is all about in today's class. So we have studied in today's class, that is alkaline storage cells or the nickel cadmium cells under alkaline storage cells. Thank you.